Hi, welcome to one another lecture on measurement in physics. This is Naveen Hegde from vidyanilaya.com. Now let's get straight into it. What is counting? What is estimation? And what is measurement? Counting is simply when you can count with your fingers or with your head, which is 1, 2, 3, 4, etc. Estimation is an imaginative concept or it's a comparative thing where you can say this object is larger than this object, this object is smaller than this object. It's a comparative thing, whereas measurement is where you are measuring the exact thing, where you're saying 3 kilometers, 4 minutes, 90 seconds, 15 degrees Celsius, etc. But how do you measure things? You measure things using counting as well as estimation, because while saying 3 kilometers, you're saying 3 as well as you're saying kilometer, which is a standard of measurement, which you're comparing it to. Did you know that kilometer is a unit of calculating and a unit of measurement? So the next question comes, how many physical quantities is required to describe the universe? As you saw, we can define any quantity in terms of physical quantities like 3 kilometers, 2 seconds, etc. How many physical quantities are required to describe the universe? It was found that only 7 fundamental quantities can describe any physical quantity via some combination. The physical quantities independent of each other are called fundamental quantities, and any physical quantity derived from these 7 are called as derived quantities. Now, unit of measurement. Every measurement is a comparison. We need a standard measurement tool. A standard using which any other quantity can be measured is called a unit. Requirements of a unit are it must be precise, reproducible, invariable, and universally acceptable. Why is it? If a kilometer definition of a kilometer changes, it can't be a unit of measurement. Which is why it must be precise, it must be reproducible, which means someone in India, if they are referring to something as a kilometer, it must be reproducible where someone in USA can still call a kilometer a kilometer. It must be reproducible, invariable, and universally acceptable. That is the requirement of a unit. System of units is a set of fundamental units. Different region used to use different units. For example, CGS, MKS, etc. CGS stood for centimeter, gram, second. MKS stood for meter, kilogram, and seconds. Then, in 1971, the 14th General Conference on Weights and Measures chose 7 fundamental units, which is called as System of Units (SI unit). Le Système International des Units. These were the 7 fundamental quantities or SI units using which any other quantity could be measured, and this is the standard system of units, which is meter for length, kilogram for mass, second for time, Kelvin for temperature, candela for luminous intensity, ampere for electric current, and mole for amount of substance. Supplementary units in SI. Radians and for plane angle and steradian for solid angle. There was a need to again to do some more research, and they found out that they need more supplementary units in SI. Now let's go to the official definitions of each of the physical quantities. Length, how far, how big. The SI unit of length is meter. It is officially defined as the distance traveled by light in vacuum during the time interval of these much seconds. Mass. Mass measures the amount of matter contained in an object. The SI unit of mass is kilogram. 1 kg is a mass of platinum iridium cylinder at International Bureau of Weights and Measures near Paris. There are some replicas made of this cylinder and kept in various countries, which measures the mass or 1 kilogram very precisely. Time. How long? When? The SI unit of time is seconds. 1 second is the time taken by these many oscillations of light emitted by a cesium-133 atom. Now, what is the requirement to have time? A standard unit of time? The requirement is that everywhere you go, wherever you go, the time should be standard. Otherwise, you will get lost with if the if there's no standard unit of time. Your watches, etc., which calculates time, came first, and then the official definition, which is these many oscillations of light, came second. There was a need to define time with a standard quantity. Now, prefixes for SI units. These are some of the prefixes of SI units. 10 to the power 21, which is defined by the prefix iota. 10 to the power 18 is defined by the prefix exa. 10 to the power 12 is defined using the term tera. You might have heard terabytes, exabytes in the computer science kind of fields, where you see the memory of or storage capacity of a system or some quantities. Similarly, gigabytes, etc. Giga is a prefix. Bytes is just like a fundamental quantity. It is a term used in computer science. Similarly, mega, kilo, kilometers, hecto, deca, etc. What are these? These are of factors of scale. Next, we have negative prefixes or negative factors, which is decimeter, centimeter, millimeter, micrometer, nanometer. Meter is a physical quantity, whereas nano is a prefix. Similarly, you can have pico, atto, and zepto. Next, we have laws of exponents. If a quantity is repeated or multiplied so many times, then that becomes the exponent. For example, 10 into 10 into 10 into 10 gives 10 power 4 or 10,000. Similarly, if you divide something, you can easily have 10 power 2, 100, etc. Now, what is exact measurement? Zero point 0.1 mm can be again measured, or it can be compared to 0.0001 meter. Similarly, zero point 0.1 centimeter is nothing but 0.001 meter, and 0.1 kilometer is nothing but 100 meter. So the counting method changes, whereas the quantity remains the same, whereas the physical quantity remains the same, whereas the prefixes for the units changes, and you can get different numbers between that. A little shortcut we have is when you have 10 to the power negative, you need to go left, which is when you have 0.1 centimeter. Centi is nothing but 10 power minus 2. So 0.1 into 10 power minus 2 is 10 power minus 3. Now we have meter, centimeter. Similarly, one another trick is to go right if you have a positive power, which is 0.1 kilometer. Kilo is 10 power 3. So go to the move the decimal place towards the right, which makes it 100 meters. Units are to be treated just like any algebraic quantity. For example, dividing 40 kilometers by 4 seconds gives 10 kilometers per second, which is nothing but 10 per 4 meter per second.